Let's now take question number 23. It says that we have to find all points of discontinuity of the function defined by sin x over x when x is less than 0 and x plus 1 when x is greater than or equal to 0. So clearly we can see here that function has two definitions, one on the left of 0 and another on the right of 0. But still, since we have to find all points of continuity, we will be checking for all the values of x in real numbers. Okay, so when x is less than 0, when x is greater than 0 and at x equal to 0. Now when x is less than 0, function is defined as sin x over x. Okay, which now here it is defined at all points except at x equal to 0, but here we are checking at x less than 0. So this is continuous being a rational function since x is not equal to 0. Now when x is greater than 0, fx is equal to x plus 1. Now again is continuous being a polynomial. Now the only thing left is to check at x equal to 0. So at x equal to 0, first we find the value of the function. Clearly from the question, the at x equal to 0, fx is x plus 1, so 0 plus 1, which is 1. Now left hand limit x tending to 0 minus fx is equal to limit x tending to 0, we drop the negative sign and replace fx with definition on the left, which is sin x over x. Now this is a standard result which gives us 1. Right hand limit x tending to 0 plus fx is limit x tending to 0, we drop the positive sign, replace fx by definition on the right, which is x plus 1, which gives us 0 plus 1, which is 1. Clearly left hand limit equal to right hand limit and is also equal to the value of the function at 0, and it implies that f is continuous at x equal to 0 also. This implies that there is no point of discontinuity. Right. Now the same way we can check question number 24, but there is a slight difference in question number 24. Question number 24 says fx is equal to x square sine 1 upon x when x is not equal to 0 and it is equal to 0 when x is equal to 0. So here the difference between the previous question and this question is that there is a single definition of the function all across except at x equal to 0. So again the same way, here we have at x equal to 0, x greater than 0, x less than 0. So we will check at x equal to 0, but for x greater than 0 and less than 0, there will be a single category as x not equal to 0. Okay, so here let's now clearly at x equal to 0, we have the value of the function is 0. Now limit as x tends to 0, fx is equal to limit x tending to 0, x square sine 1 upon x. Now this gives us, when you substitute, this will give a 0 into the limiting value of this. This is 0 into limit x tending to 0 sine 1 upon x. But here we know that sine always lies between -1 and +1, and here the only point at which 1 upon x is not defined is at x equal to 0, but since we are considering the limiting case, this is something in the neighborhood of x equal to 0, but not at x equal to 0. So this gives you 0 into a finite quantity which is 0. So clearly we have limit x tending to 0 fx is equal to the value of the function at x equal to 0, which gives us the function is continuous at x equal to 0, and at all other values also this is continuous because of the product of two continuous functions. Now let's continue with the next kind of questions, which is question number 26 onwards. Now question number 26, fx is defined as k cos x upon pi minus 2x when x is not equal to pi by 2 and it is equal to 3 when x is equal to pi by 2, and we are given that this function is f is continuous at x equal to pi by 2, and we have to find the value of k for which this will be true. All questions from question number 26 to 30 are extremely important and they are in the same category. Now here we have to check, now we don't have, since it is given to be continuous at x equal to pi by 2, here we check only at pi by 2. We don't check continuity at any other point. Okay, so at x equal to pi by 2, the value of the function is given as 3. Now left hand now here, since there is a single definition of the function for all points not equal to pi by 2, so we don't consider the left hand limit and the right hand limit separately. So simply we check limit x tending to pi by 2 fx is equal to limit x tending to pi by 2 k cos x over pi minus 2x. Now clearly it is a question which comes in the category of change of limits. So changing the limits, we get, now put x minus pi by 2 as t. So as x tends to pi by 2, t tends to 0. Now when you put x minus pi by 2 as t, so x will become pi by 2 plus t. So therefore the function becomes limit x tending to pi by 2 fx is equal to limit t tending to 0. In place of x we will write t. So what do we get? K cos pi by 2 plus t upon pi by 2 minus 2x will be, now first of all you write pi minus 2 times pi by 2 plus t. So this becomes equal to limit t tending to 0. Now this is in the second quadrant. In the second quadrant cos is negative. More so about the y-axis, that is pi by 2 plus t, cos becomes sine. So you get minus k sine t upon. Here this becomes pi minus this becomes 2t. This and this gets cancelled and we are left with, this is equal to limit t tending to 0. Now minus k sine t upon minus 2t. Negative sign gets cancelled. This can be written as k by 2 limit t tending to 0 sine t over t. But sine t over t in the limiting case as t tends to 0 is 1. So this gives us k by 2 into 1, which is k by 2. Now given that f is continuous at x equal to pi by 2, it implies that the limit x tending to pi by 2 fx should be equal to value of the function at pi by 2, and this gives us limit x tending, this gives us, now limit x tending to pi by 2 is k by 2 is equal to value of the function at pi by 2 is 3, and this gives us k equal to 6, which is the answer. Same way you can try question number 27, 28 and 29. I will quickly take up question number 30. Now question number 30 is also in the same category, but it involves two variables a and b. Now fx is given to be 5 when x is less than or equal to 2. It is given to be ax plus b when x lies between 2 and 10, and it is equal to 21 when x is greater than or equal to 10. Now we are given that this is a continuous function. It means it is continuous at all points lying in the interval, lying on real numbers. So what we do is we will check continuity. So very obviously when x is less than 2, fx equal to 5, which is continuous being a constant function. When x lies between 2 and 10, fx equal to ax plus b, which is continuous being a polynomial. And when x is greater than 10, fx equal to 21, which is again continuous being a constant function. So the only points which are left to be checked are x equal to 2 and at x equal to 10. Now when x is equal to 2, the value of fx is 5. So left hand limit is limit x tending to 2 minus fx is equal to limit x tending to 2. Definition of the function on the left of 2 is 5, which is 5. Right hand limit x tending to 2 plus fx, which is equal to x tending to 2. Definition on the right is ax plus b, which gives us 2a plus b. So we get, from here you get, if the function is continuous, now f is continuous at x equal to 2, it implies that 2a plus b equal to 5. Let's call it equation number 1. Now at x equal to 10, f10 is equal to 21. Now left hand limit is limit x tending to 10 minus fx is limit x tending to 10. Definition on the right of on the left of 10 is ax plus b, which gives us, in place of x we will write 10. So this gives us 10a plus b. right hand limit, limit x tending to 10 plus fx, which gives us limit x tending to 10. Definition on the right of 10 is 21, which gives us 21. But f is continuous at x equal to 10. It implies that 10a plus b equal to 21. Now solving for a and b from 1 and 2, we get from 1 and 2. Since we know that the function is continuous at all points, so in particular at 2 and 10 also. Now we get two linear expressions of a and b. So let's solve that. So we have 10a plus b equal to 21 from 2, and multiply equation number 1 by 5. We get, or we simply write 2a plus b equal to 5. Subtracting equation number 1 from 2, we get, here we get 8a, and this gets cancelled, equal to 16, and this gives us a equal to 2. Putting in any one of the equations, so equation 1 gives us 2 into 2 plus b equal to 5. This gives us b equal to 1, and thus we get these two answers. So thank you.